It's a real pleasure to be here, and in my final year as a Pappalardo Fellow, I certainly share many of the wonderful memories that Jocelyn shared with you earlier. Today I'll be talking about the research that I did here at MIT and am still doing as a Pappalardo Fellow, which is research looking for dark matter particles in the laboratory. As Jocelyn alluded to in her talk, about 94% or even more, 96 or so percent of the universe is unknown to us. We know the gross anatomy of it, but we don't really understand the fundamentals of it. And a huge contribution to that missing content in the universe is dark matter. These are particles that do not interact with light, do not radiate or absorb light, and it's some fundamentally new particle that we don't yet understand. So the research that I work on is the construction of an apparatus in a laboratory to look for the interaction of these dark matter particles with atoms in the detector in the hopes to characterize the particle nature of dark matter. So why do we think that there's dark matter, and where did this whole idea come from? So this turns out to be a mystery that was handed to physics by astronomers and astrophysicists. This is an optical image of the Coma cluster of galaxies. This is taken with an earthbound telescope. And if you look at all of the blobs in this picture, they're basically, each blob is a galaxy. And these galaxies are gravitationally bound into a system called a cluster of galaxies. And this object, the Coma cluster of galaxies, was studied by a Swiss astronomer named